Hey, Geometry. This is Mr. Bloom. This is 9.6 Compositions of Transformations, our last new piece of information before we review for our test. So we have a review here for what is an isometry. And we've gone through this a few times. So an isometry is when the pre-image and image stay the same size and shape. Isometry, pre-image, image, stay the same size and shape. Keep that in mind. Which transformation's not an isometry? Okay, we have translations. Okay, those are slides. We have rotations, they are turns. We have reflections, those are flips. All three of those stay the same. So the one that doesn't is a dilations. Dilations are not an isometry because pre-image and image shapes are similar, not congruent. So to review a dilation, you find the image of each point for the given scale factor, okay? So we're looking at a dilation with center 0, 0. So if I find the image of each point with the given scale factor, all I'm going to do is when I go from D, or A point, like a point A, when I have X, Y, I'm going to go to A prime and be KX, KY, because I'm going to multiply my X and Y coordinate values by K. So what that means is I'm going to multiply this by 2. Okay, so I'm here. Right here, I'm going to take that 2, I'm going to multiply 1 by 2 and negative 5 by 2. So this becomes an enlargement because 2 is greater than 1. What I'd like you to do is determine if it's an enlargement or a reduction after you finish doing that. Go ahead and do the next two. Okay, so hopefully you know that 1/3 times 0 is 0, and 1/3 times 6 is 6. All right, excuse me, 2. So I've got that, but it's a reduction because the 1/3 is between 0 and 1. Now, in this one, this is kind of tricky because when I multiply 10 times 0 and 10 times 0, I get 0, but it's an enlargement, not because of the result, but because the value that I'm multiplying by is greater than 1, it's got to enlarge the figure. Okay, now we have this picture, we have the center of dilation here, it's R, and as we draw out lines, okay, from our point of dilation, our center of dilation to an original point out to our image point. So this is our pre-image here because this doesn't have any primes on it as we drive out here. And when it's on the other side of the center of dilation from our original point, it becomes an enlargement, okay? So now we've got this going and I've got which one is the image. We've got this as P prime, Q prime, S prime is our image because that's the bigger one here, but not because of the bigger one, because of the notation here, P prime, Q prime, S prime. So now, if RP is 3 and PP prime is 6, RP is 3, so this is 3, and PP prime is 6, and this is 6, we've got to be careful here because I've got a setup going this way. I've got K R prime P prime is equal to R over P. So we put our primes on top when we're finding our K value, but keep in mind, our center is not only R, but it's also R prime. So I have my distance R prime P prime is 3 plus 6, which is 9. Okay, and then I have our distance RP, which is just 3. And our growth should be 3. So K is equal to 3 overall. and it's always about corresponding distance. You got to think about the corresponding distance from R to P and R to P prime. I mean, I could go on PQ here to P prime Q prime. Those are corresponding distances. Always think corresponding distances when you're finding your K value. Okay, now let's look on here. We have compositions today. Now, This is new stuff, but when we're talking about compositions, a composition is a combination of other isometric changes or other transformations. I should say other transformations because not all of them have to be isometric. So this first one we're looking at here, let's get a pointer back up here. And let's do that with this. And we'll go back here. So now I've got a pointer going here. A composition of transformations is when you do a sequence of transformations like a translation followed by a reflection. So I've got a translation here. I'm going to take my original shape, okay, and I'm going to slide it across, okay, and then I have a line of reflection parallel to the line of translation. I'm going to flip over, okay. So I've got that parallel line. That line is parallel to my translation slide, and I reflect it over here. This particular combination is called a glide reflection, okay? So I've got to keep in mind when I'm doing something like this, it's kind of like a walk in the sand or something like that. But this is a glide reflection. It's a translation. I go from A to A prime to A double prime, okay? And my reflection is over that line of that parallel line of reflection to my translations, because my translation went this way, the line of reflection is parallel. Line of reflection is parallel to translation direction, my slide direction. Okay. So we've got to answer a question over here. Is a glide reflection isometry? Well, I have this and this, and I flipped it over, and it is. It's an isometry. Yes, preimage and image are the same size and shape, so that guarantees it's being an isometry. It's isometric. Okay, so we're here at this next page working on compositions. A composition is a combination of two or more translations. So here I've got -2,5 after reflecting over the x-axis and rotating 90 degrees clockwise. I'm going to use those rules. Reflection over the x-axis, okay, that's here. 90-degree clockwise is here. Well, I'm going to do this, and I've got my original point there, -2,5, and now I just apply my rules. So -2,5 becomes 5, -2, -5. Okay, when I put those in, 90-degree clockwise, as I spin this around the axis, I actually get this 90-degree clockwise, and I apply my rules at -5, 2. Oh, I lost my head, my arrow. Okay, group. Now, keeping that in mind, that's my answer. I'm going to do the same thing on this, or I should say something similar. I'm going to first write my rules in that I need to do, and I got my translation, my original. So I've got 0, 7. I'm going to add 1 to the x and subtract 4 from the y. So I become 1, 3. But I still have this other line, reflection over the line x equals 0. Well, I got that rule as well. That happens to be the same rule as y-axis reflection. So I change my x and keep the y the same. So now these are my two answers for these two compositions, and it was exactly what we've done before, except now I just keep applying rules on my from my pre-image to my image, and I go from my image to my next image. Okay, so now let's see how this looks in the coordinate axis. So first thing I'm going to do is I'm going to plot my original points, and I got these plotted. I've got a reflection over the x-axis right here. So if I reflect these over my x-axis, those are going to be my values based on my rule. And again, my rule, -3, -2, and -5, they all stay the same because x stays the same. Y take its opposites. Okay. Now I'm going to take and do a translation and add 9 to all my x's and add 2 to all my y's, and I get this. Well, what this looks like on my axis is, first of all, reflection across. Everything is on a perpendicular line. I walk to the line of reflection and I'll walk away. So I've got this. That's my blue rules change. And then I translate over 9 up 2, and I get my new rules. Okay, so I'm here, and those are the same points here. So my final position, and you guys have on your sheets a single prime, and that would be these answers. But it really should, we're looking for the final resting place. So these should be these guys, okay? 6, -5, 7, 1, and 4, 0. Okay, so now we got this idea of composition, and let's do this next one. So I've got a triangle, LMN, with the vertices L03, M34, and N12. I'm going to rotate them 180 degrees about the origin, and a dilation with scale factor 2. Okay, so I've got my original points, 0, 3, 3, 4, 1, 2. And I'm going to rotate them. When I rotate them, all those lines, those points, I take the opposite of my x's and the opposite of my y's. Well, what that looks like on my graph is I have a point, and if I take the opposite of my x's and y's, I go to L. The opposite of my x's and y's, so the opposite of 0 and -3 becomes down here. So this is my L. And this is my n prime, which is -1, -2, -1, -2, and my m double prime, my n single prime, -3, -4. So I've got that going on, and those rotated through, and I know this is a rotation because corresponding points line a line through the 0, and that gives me my angle of rotation. L to L prime, M to M prime through 0. 0 is my center of rotation. So that's my rotation. Okay, but now I'm supposed to dilate with the scale factor of 2 using the origin as the center. So now I've got this dilation k = 2. This is going to blow it up. I'm going to multiply 2 times each my x and y coordinates. So 2 times 0 is 0, 2 times -3 is -6, 2 times -3 is -6, 2 times -4 is -8, 2 times -1 is -2, 2 times -2 is -4. Well, I put those over here on my graph, and I recognize, and I've got to get my graph a little higher, that my points 0, -6 is going to be down here, and my dilation is an enlargement, okay, because 2 is bigger than 0. So this is my final resting place, and so I'm here. But keep in mind, this is my answer for A, and this is my answer for B when I'm stepping through this problem. And it is also the same as far as my answers for A and B in my other problems. So when I listed them as sets of points, it is clearer what they are. Makes it easier for you to know you're done with the problem, along with easier for the grader to grade the problem. So make sure you get used to listing your points out. I hope this stuff makes sense, and if it doesn't, you're going to have to ask your local geometry teacher any questions that you might have. But again, as always, I'm Mr. Bloom, and you're not. Have a great day.